might get kicked out. Just jump back in. So yeah, so I have all the tests graded, and I'd love to get all that stuff back to you so it's more meaningful. If I wait 2 weeks and then you get back, you're like, what? All right, we'll probably be done with this next chapter in 2 weeks. That's how quickly this one's going to go. And so I want to give you the handouts from yesterday in case you didn't print them, which I totally understand. If you have a copy, then take it out. But we did some new stuff yesterday, and I left it up. But I want to kind of help you maybe recreate that in case you didn't get a chance to. Because having it on this handout, I think, is going to help you do better as we keep going. Do you need one? Or are you looking for? Okay. So if you didn't get a chance to do this yesterday, we'll do it now. If you did do it yesterday, then this first little while is going to be nice and easy for you, and you can just kind of like make sure that it all makes sense as you go. You take one of okay, and we are going to start that new idea like we did yesterday. I want to work through some of it with you again today so that we're all caught up, okay? Now, the thing that I'm going to have to do a little bit back and forth is jump to the back to help you see where all this stuff comes from, what it looks like, and why the pictures look the way that they do. Now, you guys in front of me, I apologize for yesterday's video. I was jumping between a couple different laptops, and it only really captured the audio from one computer and not the video all that well. So if you miss class, you have no idea what's going on. Okay, and so what we're doing now, so having this piece of paper I think is really nice, but there are some ideas that you might want to write down separately, like, bless you, like in your notes, because there's just not enough space for you to do that. So in addition to that piece of paper you have sitting in front of you, you should probably take out your notebook, okay? Because that will give you a chance to jot down some of the main ideas, some of the how-tos on what's going on. I promise you there's not enough space. I know it looks like a lot of empty space on that page, not nearly as much space as you think, okay? Because we're doing something new. We're doing something pretty quick, though, which is nice. And that's why I'm kind of doing this one next, because the chapter after this, I had like 2 choices on what I wanted to do next, this or something else. And the other one is a little bit longer, and it's like super, super brand new with some new ideas. And so I thought that might not work as well. So I'm going with this one instead, and I think it's the right choice. So what you're going to see, hand down, come back. Ooh, hello. Is that we are starting new ideas, things that you've never seen before, in what I'm calling chapter 3. And we are looking at inverse functions. If you do not have enough room on that handout that I just gave you to write this stuff down, so I would write it down separately in a notebook. And this is new. You don't know how to do this. And so I think it's worth writing. Now this is, I'm just kind of recapping yesterday. So if you're at home and you already did this yesterday, then relax and enjoy some downtime while I get my lovely cohort B folks all caught up. No, but if you were good with yesterday, then again, you don't have to necessarily jot this stuff down if you already wrote that. But if you didn't, you should write it, right? And let's kind of think about it. Like, what is, like, you see, all right, functions, I know what functions are, but what's inverse? What does that mean? Don't even care, I don't, not math, but just inverse. Opposite, that's all it is. When we look at inverse functions, we're just getting the opposite. Like, they're going to give me a function, I'm going to give you the opposite, right? So we're going to be given some function. We're going to be given a function. They're going to tell us what it is usually, right? They're going to say, okay, here's f of x. There it is. Cool. Now, they could call it f of x or g of x or h of x or whatever, right? It doesn't matter. They could call it y, right? Whatever they want to do. So that's how it's going to start. And our job is to find the inverse of f of x, or the inverse of y. And you're just going to see, like, all right, the function started with an x, it's still with an x in it. It's just all of the opposites. We're just going to undo everything that's kind of happened along the way. Okay? Now, this is kind of a long way to write that down, right? The inverse of. And so we've got some inverse notation that just makes it a little bit easier to write down. But when I get to the end and I say, oh, hey, this is the opposite of what you gave me, I don't have to say all those words. I don't have to say any of those words. I can just write some symbols, okay? And this is what those symbols look like. Got the F, because it came from F. If it was G, it'd be G, H, whatever. It's just got this little -1 in between. Now, it's not really an exponent, but it is in that kind of that exponent spot, okay? But I'm going to read it out loud exactly like this, the inverse of f of x, or like f inverse of x. If you wanted to like really read it like letter by letter, like f inverse of x. Or, same thing with y. Just put a little -1 kind of up in that exponent area. And seriously, everything just switches. It's just the opposite. And it's so much so, in fact, that the key, this is the whole thing. This is what I said yesterday. All we ever really have to do is switch x and y. You're going to hear me say that like 10 times. Oh, what should we do? Switch x and y. And then we'll go from there and see what happens. Switch x. Okay. And I think the easiest way to start with this is to look at things visually, and then we'll kind of mess with the algebra after the fact. So that's why you're going to see on this handout, and I'm going to switch over here. On this handout, we've got lots of space to do some algebra, but there's also space to do lots of other things as well. And so what I want to do is just kind of start with this first one, that y equals 3x minus 2, and start thinking about what it takes to draw that. Well, if there are no squares or cubes or square roots or weird fractions, like what does that graph look like? 3x minus 2. It's just a line. What do we need? Something to make it. Okay. And so we're always going to have a straight edge to do this because it will help us obviously draw a straight line. Okay. Now, for me, it can be kind of tricky to graph other things. Like lines aren't so bad, but even lines, I just don't want to mess it up. And so what I like to do, anytime they make me graph something, is I like to create a list of points to make it really easy for me to do that. So I just make this little XY table. Now, if that was f of x equals, then I would put x and f of x. Or if it was g of x, okay, x and g of x. But it's just x and y. I'm just going to follow that. Here's what I don't want to do. I do not want to plug a whole bunch of numbers in by myself and figure out which ones work and which ones don't. And so instead, I'm going to let the calculator do all the work. Video for a second. I know. I'm going to share my screen in a second, so don't worry about the camera being off. Now, I don't know what to do about this yet. The fact that most of us do not have a graphing calculator that looks like this. Because, man, does this make this whole chapter so easy. So if you don't, what are we going to do about this? I'm still thinking about how to make this easy for you. But if you have a graphing calculator, take it out. We're going to use it all chapter long. And we're going to be using it next chapter too. And so when your 9th grade math teacher said, hey, you know what? It's a pretty good idea to buy this calculator. Can't make you do it. I can't make you spend $100. But you really should, because you use it for 4 years. Here we go. Okay. The thing that I'm thinking about, seeing if it's worthwhile, is seeing if I can find a free version of this software. Okay. This is obviously, I mean, it's the graphing calculator. It's the TI-84 Plus, right? But Texas Instruments, TI, that's what. This is not free. Right? The school bought this for me as a teacher, so I could do this. But is there a Texas Instruments emulator that looks like this? Sweet. Is it free? Awesome. So I will see if I can find the links to both Android and the App Store. The App Store. See if I can just like share that out with you guys. You can find. Okay. Because if I want to just graph 3x minus 2, so here I am just typing that into y equals. I would love to just have it create that table for me. Now, hold on a second, because look at the space that we want to work in. Let's see, did I open up the right one? Nice, good. Right? Negative 10 to 10, negative 10 to 10. That's where I want to live, right? And so any points that don't fall in that space, like single digits or 10, both positive and negative, and both x and y, I'm not going to worry about using, right? And so it would be really nice if the calculator could do all that work. Give me a table and help me find those kind of points. Do you know anybody that is familiar with the calculator? Like where to go? Yeah. So there's 2 spots, right? And I know people at home can't see what I'm circling right here, but above graph says table and above windows says TBL set, that's table set. So you can set up your table to look how you want, and then you can go to that table. So I'm actually going to do that. I'm going to go in that order. I'm going to go to second window. So the second window. But right now my table is starting at -3. Let's start at -10, right? That's the x values. We'll go up by 1, so I don't have to worry about decimals and fractions and stuff like that. And it is automatically going to spit out all the numbers for me. And so I can just go second graph, click on, which is basically pick a table, and there it is. But look at my first number. Sure, -10 is good, but can I fit -32 on this graph? -29? -26? No, I can't fit any of these numbers right here. I can't fit any of those numbers right there. So let me scroll down a little bit. Even -3, -11 doesn't fit. -2, -8 does. And that one, and that one. And I'm just pressing the down arrow so I can see more of the table. Right? Those are the points right here that are going to fit on this graph. And if those are the points that fit, those are the points that I'm going to use. But that's what I'm going to do. I'm going to go to my table that I'm going to write down, and so I'm going to take you all back with me. I know you just lost it. I'll write it down. But having that table is so easy. Just be like, you know what? I don't have to plug any numbers in myself. I just let it do the work for me. And I create a table. Right, I create a table that says, all right, you know what? My calculator told me that all those numbers, like -10, -9, -8, -7, none of those are going to work. But once I get to -2, that's got a -8. And -1, -5, 0, 1, 2, 3, all the way down to 4. -2, 1, 4, 7. All those points are going to work. Once I have those points, then I can go. I can't keep going crazy going back and forth like this. So I'm going to hook up my other one. I just don't have the emulator on this one, but this will help me actually graph it with you. Bring the camera back. But that's what I want to start with. But the other thing that I want to do is I want to get a table of values for the inverse as well. But I don't want to leave it as like x and y, because then there's nothing to tell the difference between this one and this one. So let's just write it like this. Let's put that little -1 right there above the y. You know that table is not just any x, y, but it is exactly the opposite of what we just did. Okay, well, how are we going to fill out that table? How should we do it? So you're going to take this whole list and switch. That's it. Super, super easy. Your x's are now your y's, -2, -1, 0, 1, 2, 3, 4. Your y's are now your x's. And that's it. Your table just it's a pretty simple concept that has really far-reaching ramifications once we actually see it. And now I want to graph it. And so here's where I think, if you want, it's a great opportunity to use two different colors, one for your function and one for your inverse. And so if you want, take a pen or a marker or something, or grab a colored pencil that has some sharpness to it. If you want. You got something? I know you're already one. You have to work hard. You good? Take one. I think it's just helpful. I don't know that you need one, but I think it can be helpful. As these graphs get a little more funky looking, I think you're going to appreciate having two different colors. That's all we need. We're just going to graph the function and its inverse at the same time. All right, you come with me. Okay. So turn this way if you think it's helpful. Hopefully you guys can see that. Okay, let me take a look at your view. That's pretty good. All right, cool. So I'm going to go to the graph. I'm going to blow it up. I'm sorry for the blinking. My light is fading on me. But I'm just going to plot those points. But I got to talk to you pretty specifically about how we want to do it to make it look as best as we can. All right, so I'm going to pick a color. I'm going to go blue. And seriously, I'm just going to plot the 1, 2, 3, 4, 5, 7 points. -2, -8. Put a point. You do it. Go ahead. You have a graph. You got a table sitting in front of you. X first, then your Y's. All right, so you move kind of left and right to wherever the X value is, and then you go up or down to get to that Y. -1, -5, 0, -2, 1, 1, 2, 4, 3, 7, and 14. And there it is. There's that line. Everything's all nice and lined up. Now, I think the best way to draw those straight lines with that straight edge, I said this yesterday, it's not about lining up the first two or the second two or the last of the third, whatever. It's about lining up the first one and the last one. Making sure you can see both of those the same width away from your ruler. All right, so here's my ruler. What do you think? Pretty nice. Line it up. Lining up the first one. I'm just kidding. I'm not going to use this straight edge. Line up the first and last one. I'm going to freehand it. I have to. And connect. And of course, I mean, sometimes we draw lines, sometimes we'll draw parabolas, sometimes we'll draw circles, we'll draw whatever the graph is. And what's so nice is the table will just give us the points. We just jot it out. Right? Now, but this graph keeps going. Right? This graph, just because I plotted the 7 points doesn't mean it's the whole graph. Obviously, I had to scroll through my table to get there. There's lots more points. There's an infinite number of points on this. How do we draw that? How do we show that this line keeps going? Yeah, arrows on each side. So I'm already at the edge here, so I can just extend it a little bit and throw an arrow on the end. Down here, though, I'm not on the edge yet. And so you want to like continue your line down and then put the arrow on the end once you get there. The key thing is that you've plotted all of the points that you can. You cannot cross that next grid line. Because if you were supposed to, then you would have put a point. There would have been a point at -3, comma, whatever. But there is no point, so don't cross that next grid. And then I just do the same thing with the inverse. I have a table of points. There they are. Sweet. I'm just going to plot it. -8, -2. Put a point. -5, -1. Put a point. We're just graphing a function and its inverse. 1, 1. Ooh, look. Okay. Yeah, switch 1 and 1. It's still going to be 1 and 1. So it's going to run into it right there. 4, 2, 7, 3, and 7. Don't be surprised. The inverse of a line is still a line. It's just sideways. Line them up. connecting with the straight edge. This one's already at the edge, so I can just extend a little bit, put an arrow. This one's not at the edge yet, so I want to extend that out, making sure I don't cross that grid line that I'm getting closer and closer to. There it is. That's why I like to have two different colors, because it's super, super obvious what my function is. That one's this, call that y right there. Here's my inverse, the inverse of y. And I don't think I did that yesterday, labeling that. So if you've already done all that, maybe throw some labels on your lines there. A little y at the top of my blue one, and a little y inverse, or the inverse of y, however you want to say that out loud. That goes. Okay. Now, here's something that I want you to do. Can I steal this for a second because it's so lovely? Take a look, right? We've got these two graphs, right? Here's what I want you to do. Physically, like, pick up your paper like I did and rotate it, like bring the staple side down so it's 45 degrees. 0, 90, 45. So that your graph is just sideways, right? Where like the top right and the bottom left are now kind of right on top of each other. You see that like perfect X right there, right? Can you imagine the line that would just split it right down the middle? That goes from the top right to the bottom left. We're always going to draw that line in, and you just kind of like top right, the bottom left, with a dotted line. Down one over one, down one over one, down one over one, down one over one, down one over one. I'm freehanding it. You can just line. Obviously, you have straight edges. You can just line those up. You are drawing in the line y equals x. And I promise that will always, 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 always be that line that cuts your two functions in half. I don't care what your graph look like. I'm going to come up here. I'm going to bring the camera with you here in a second. You will always have a line of input at y. Always, always, always. Because look, y and x just switch. So there's your symmetry. Sure. There you go. Just that little part there. You always, always, always have a line. We're just always going to draw that in. It's always going to be it. It just makes things up. Cool. That's the visual side. The calculator gives you a table, switch x and y to get there, and then graph and see what happens. The algebraic side, I already have the how-to written up over there from yesterday. I'm going to leave it there for you guys to jot down. I would probably put that in your notes, not on this handout, because that's what we're going to do. We are going to start, of course, by just writing down the function, whatever it is. Okay, so here I am. Y equals 3x minus 2. Hey, what do you think we should do first? Switch x and y. Literally, switch them. X is now y, and y is now x. Now, if you have to, like, if they give it to you as like f of x or g of x equals, I think it's a good idea to write it as y equals, so you can just switch x and y. So I called that step 0, because sometimes you don't have to, right? This is y equals already. I didn't have to make the switch. So step 0 in my mind, write it as y equals instead of f of x, or g of x, or h of x, but then switch x and y. And all I want to do is figure out what that inverse looks like. And so we'll just solve for y. And to make life easy, it's easier, there'll only ever be a single x and a single y, so you only have to switch those two. It won't be like x squared and x in the same problem. I'll just have one x, we just have to go. Okay, so switch x and y, and then we solve for it. And I solve for y exactly how I've always solved for anything, right? It's just that you still have x and y in the problem. Like, they're not going to go anywhere. We're just going to move stuff around. And it's this right here that I want to get by itself. So what do you think? All the action over here on the right, what should we do first? Oh. Do the opposite. Good. Yep, so a little plus 2, sweet, so those are gone. And so the left side gets a little more complicated, right side will get a little simpler. But, okay, so right side is just the 3y that's left over, but how do we write that left side? Exactly as it's written, right? We just put them next to each other instead of on top. X plus 2. And the addition and subtraction part is done. Okay, now look. Keep solving for y. Get this right here by itself by moving the numbers away. Divide by 3, right? Big fraction on the left and right. Perfect. I don't have to worry about like going super crazy with it. I just kind of take care of whatever's there. Cool. The 3's cancel. So y equals, good, love it. It's exactly as it is. You don't have to worry about changing a single thing. Like I said, the right side's going to get simpler. The left side's going to get more complicated as we go. Is the y by itself? Then we did it. We solved for y. All I want to do is just use that inverse notation. If it started as f of x, then I would write it like this. If I started with g of x, I just put a g. But it started as y equals. I know like the y on the right bothers me, so I always like move the y back over to the left just by kind of like flip-flopping these. Put that in the middle. X plus 2 over 3. And you're done. Right? So, and as things get more complicated, there'll probably be more steps of algebra that we have to do to get the y by itself, but it's always the same process. And at this point, gosh, we've done so much solving. You guys are pros at it. So I think that part of this is the part that you're most comfortable with. It's just, you still have x and y in the problem, and no big deal. It's all good. And seriously, that's the whole chapter. That's all we really need to be able to do. We just have to do it with slightly more complicated looking things and then make some pretty cool graphs. And that's what I like about these like functions and their inverses, because they have that symmetry. They look really nice and they're worth looking at. So how's that sit with you? Is that all right so far? So calculator for sure, like saved us probably 15 minutes. Like 15 minutes, and that's crazy. Because you'd have to like plug in numbers to find the ones that work. And how do I know to start at -2 and not -10? Right? I would start at -10, plug it in. No. -9, plug it in. No. -8, and this over and over and over again. The calculator can make all of that much, much, much easier. Okay. So tables, switch x and y. Graphs reflected over the line, y equals x. Algebraically, switch x and y. It's the same thing. Everything. Okay, inverses are super fun. I like them a lot. I think they're easy once you get the hang of them, and really cool to look at once you see those graphs. Cool. All right, let's do another one. Let's do number 2. We didn't finish this one yesterday, if you did watch, so we'll get to a point where things will start to be new for everybody. But if you missed it, this is new for you, so that's good. So don't forget all that stuff I just wrote down right there. But let's do number 2. Haley, what does this say? Can you read it to me? Is it y equals again? Okay. Okay. So there's that second one. Yeah, you have it in front of you, so you're good. I'm writing it over here. Now, I know I didn't include any instructions on this. I just didn't want to spill the beans early. But I will always tell you exactly what I want you to do. Get a table for the function. Get a table for your inverse. Graph them both. Draw a dotted line through the line of symmetry, and then find it algebraically. I will always break that down for us. But I like starting with the table. I just think it's easy to start with the easy part with all the visuals that go with it. Now, again, calculator. Okay, I'm going to share my screen. I'm going to turn it around so you guys can see it. Or maybe I'll just go to the... What do I want to do? I want to do this and that. Go to the back just so you can see what it looks like. What do you think? Take a look at that function. What does that setup look like? X minus 2 squared minus 9. What kind of graph do you think that's going to be? kind of function is wrapped up here? X minus 2 squared minus 9. Any ideas what that might look like? What kind of function that is if it's written like that? It's a parabola. It's quadratic, right? It's in vertex form. I know the vertex is going to be at 2, negative 9, right? Right 2, down 9. But what I want to do is I want to set up my table, not to start at negative 5 where I left off with the last one, but start at that negative 10 to see if any of those numbers are nice. The table's going to go up by 1 so I can avoid decimals. I'm going to automatically have everything spit out. So I don't have to worry about guessing which point to go in. And look at those first ones. No way, I don't have to plot any of those. I only have to plot the ones that go. And so I can get myself all the way down to that negative 2. I'm going to scroll to see if there's some more points stuck down there. There we go. There's that collection right there. Starting at negative 2, running down to 6. That's going to be my table. So I don't include the negative 3. I'm going to leave that up back there so you guys can jot it down. I'm going to do the same here in the front, and then I'll bring the camera back with me. Negative 2, what is that, 7? Negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 0, negative 5, negative 8, negative 9, negative 8, negative 5, 0. So do this long enough, you don't have to look at the screen anymore. Oh, those aren't lined up all that well, though. Starting to get a little sloppy. Stop it, Joe. Stop. 0. Some people like to put like lines, to like light, like kind of grid lines to make sure everything's lined up nice. That's cool too. Some people like that. Kind of like a spreadsheet. And that's really what the calculator is for. Gives us a nice collection of points. And you could always press graph and look at it. Now my window's all screwed up because I was doing some calculations in different spots. I'm going to do standard. That is negative 10 to 10, negative 10 to 10. There's that window. There's our graph. We just want to make sure that we match that. So, let's make it look good. But before we actually graph it, let's get a table for our inverse. Okay, so I'm going to make it look like that to start. Let me turn my camera back on so you guys can see. There we go. But I'm missing something. Yeah, that little power negative 1, very good, right? And it's not really an exponent. It just means inverse. It's just a symbol. We didn't want to write the whole word out, so we just made up a symbol. Again, if that was F or G, then we'd use function. But it's just Y, so we're good. I like that it just kind of starts with that. And what should we do to make the table? Every single time. All my x's are now my y's, negative 2, negative 1, 0. 1, 2, 3, 4, 5, 6. Now, here's a really big takeaway from this. You're going to see that your y values that were here, right, are now your x's, and they go down and then back up again. Gosh, I'm all over the place. And there is a very important thing that we have to do right if we want to do this right. When we plot these graphs, we have to plot them in this order. We have to connect them in this order. Okay, it's going to look weird. It's not going to look right if we just kind of randomly pick what order we want to connect the points in. We're going to connect them from left to right for the function, but we're going to connect them in whatever order that is when we actually go through and make the graph function. But super, super nice. It's like, all right, you know what? There's my table. I'm going to the inverse. Super easy. I just got to switch them. And then I just take out a couple colors and I get them graphed. Well, something was leaning on the X on my keyboard. Look, this one looks really good. Oh, that lazy is going. All right. So, pick a color, plot some points. In that order. Now, here's the thing. Like you said, this is a parabola. It's not going to be a straight line. you cannot use a straight edge to draw something that's straight. Right? We're going to have to freehand our graphs unless they're straight lines. Cool. So I'm going to plot. I'm going to pick the blue to start again. That was a good one. -7. -1, 0. 0, -5. Oh, 1, -8. -9. And back up. Go. You don't have to make your points all that big, but you want to make them big enough so you can find them. Look, there's that birthday. -9. Sweet. Except the freehand. I want to be careful. I'm going to do it slowly. I don't want to get to that grid line too early. I'm supposed to get there at exactly the point. Not a minute early. I also want to be symmetric. I want to make it look as even on the left as it is on the right. And if you try to be perfect, you're going to be here for a while. We're human. We're fallible. We're going to make mistakes. Do the best. Okay. Not perfect, but I'm not going to stress about it. But if it's not to your standards, erase it. If you think it's just, man, that is way off, I can do it better, that's why we use that. But this is missing some stuff. What are we missing? Yeah, this graph is going to keep going just like old. Okay. And you see that in the table, right? We had to scroll down to get some more points, and then there were more points after that. That's your clue that you've got some more points that we have to watch out for. You guys still there? Okay, cool. So extend it, but don't go through that next grid line. Extend it, arrow at the top. Extend it, not going through that next grid line, arrow at the top. Just kind of following the flow of whatever the graph. Okay. And then I do the same for the next table. But you're going to see that this is going to take me like from 7 down to -9, and I'm going to curve back towards 7. You have to plot them in this order, or the graph will not look correct. 7, 0, 7, -2, 0, -1, -5, 0, -8, 1, -9, 2, and then back, -8, 3, -5. Where am I at? 4, 0, 5, and 7. Right, the order that you just plotted these in is the order that we have to graph. Again, extend it, throw some arrows on them, extend it, throw some arrows on them. And there's always one thing left to graph. What is this missing that we're always going to put on every single function and inverse graph? The line of symmetry. Okay, starts at the top right, ends in the bottom left. It is the line y equals x that goes to the points like 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on. I basically just put kind of a slanted line at each of those points of intersection where the x and the y are the same. That is the line y equals x. My blue one was my function. I'm going to say y. My red one was the inverse. Like next to an arrow, I just find an arrow that's kind of off the side, off by itself somewhere. And there it is. No. Yeah. Nice. Now, here's your paper a little bit. My late Valentine's Day. So we can make some pretty cool graphs. Just looking at functions and inverses. That's how far we got yesterday. My goodness. I think that was worthwhile for almost everybody in the room. If you were at home and you're like, my gosh, that was painful, I already did that. Well, thank you for putting up with that. Now, let's do the thing that we did not get a chance to do. Let's actually solve for the inverse of this function. I'm just writing it again so I can work vertically straight down. Okay. Our job always is going to end with one last thing. Let's figure out what the actual inverse of this function is. Step 0, let's see. Write it as y equals. Okay, good. It's already y equals, so I don't have to worry about that. What are we going to do? Always make the switch. Y is now x. X is now y. And really, like, that line right there is the inverse. It's just not in the way that I can do anything with it because y isn't by itself, right? If I want to plug it in my calculator, I press the y equals button. Well, I'm at x equals right now, so that's so we got to do whatever we need to try to get this little y stuck in here all by itself. At the end, y is going to be all alone, and then we'll use that inverse. So let's solve. What do you think we should do? Add 9 to both sides, right? I can't add the 2 yet. That's stuck inside, but I can add the 9. Plus 9, plus 9. Those go away. Right side gets simpler, right? The 9s are gone, so I still have y minus 2 squared. That's it, right? There's nothing I can do to put those together, and we won't be able to. That's the idea. Is we're not going to, like, simplify stuff along the way necessarily. It's just going to start getting more complicated. We're going to take stuff from the right and put it on the left. You're going to see it's always going to be the opposite. Okay, cool. So, in my mind or on paper, if you feel like it's helpful to write down order of operations and say this is the way I'm going to go to solve addition, subtraction, done. Sweet. And that's kind of the first step we did with the last one, we'll love to do. Okay, multiplication and division level. Do we have anything to multiply or divide? Sweet. Okay, then one less thing for me to do. Check mark, moving on. Okay, exponents and the opposite of exponents. Do we have an exponent? Let's do the opposite. What's the opposite of squaring? Square root. Good. Okay, so what we're going to do, and however you want to write it, but I'm going to take the square root of the left and the square root of the right. Now, maybe you write that as a whole separate step. That's cool. But the idea is that the square and the square root will cancel each other out. What are we going to do with that left side? Exactly as it's written. That's the idea, is that we can just leave it like this. There's only one little thing we have to do. We just took the square root, and it's still there. What do we need to bring along with it? Nice. Plus or minus. Now, it only has to happen on the left side, because the right side, we like undid the square with the square root, so those cancel each other out. So plus or minus is more. The left side, we're going to need that. Yay! Sweet. Done. So now we get into the grouping symbol, right? We're inside the parentheses. They don't even exist anymore because we got rid of them. That was kind of the point. And now we can go back to the beginning and finally take care of that little minus 2 by doing a plus. And y divides up. Now, how you write the left side, just like it was when we were doing, vertex form, quadratic form, or whatever, is kind of up to you. I like to put the nice number first and then the plus or minus the square root after. So I'm going to write it as 2, positive 2, so I don't need the plus anymore, plus or minus the square root of x plus 9. If you put plus or minus the square root of x plus 9 and then outside the square root of a little plus 2 at the end, that's cool too. Did it, right? Step 2, solve for y. Just equal y, whatever that takes. And, I mean, we're not going to get super crazy with it, but we'll have squares and cubes and square roots and cube roots and fractions. We'll just kind of get better at what we need to do. But we got one last thing we have to do. Last step. I don't want to just call it y equals because then it doesn't have any relation to where we start. The whole point is to say, okay, here's a function. Give me the opposite of that. And tell me for sure that this is the inverse. Okay, so you're always going to take, you're going to get to the end, you're going to write one more line of work that has that inverse notation box. It also gives you a chance to move the y over to the left. and put all the other stuff on the right, kind of how we like it. Again, if that was f of x, okay, then f inverse of x. Ta-da! Chapter 3. Now we just practice it. Now we just get better. Make sure you can do it on your own. And seriously, it might just take us this week. And that might be it. And hey, that's not a bad thing. There was no way for me to get to a point where at spring break we would be at a good stopping point in anything. If I didn't do this and I jumped right to the other one, it would take us more than 2.5 weeks to do it anyway, and we would have stopped in the middle. So we're going to do this for a little bit, test ourselves on it, see how we do. But we'll practice first. And so that's what you'll do tomorrow. You now have this in front of you. Folks at home, you'll just bring this back with you tomorrow. I'm glad we at least did something different than we did yesterday. But now you guys are all completely caught up, which is awesome. So thank you for putting up with that while we all got where we needed to be. How you feeling? We good? It's just a practice kind of thing. You've seen it. You're like, oh, I can do that. I can do that. Calculator stuff. So did you find it on the App Store? Is it just TI Emulator or TI 84?
Calculator X.
That's what it says, Calculator X? Yeah. That's what it's called? That's the app? Cool. So I will check that out, make sure it's legit for both Apple and Android. Because, man, this is going to make your life so much easier. If it looks like the calculator screen, that's what we want, so you guys can get used to that. Now, other calculators can do that stuff, but they don't have the table feature as nicely as graphic calculators. But if you find something that can, I don't care what you use, as long as you use it. Yeah. So it can graph, but will it give you a list of points like laid out as a table? So that's kind of what I'm looking for. I wanted to do all of like the organizing of the points. So the rulers and the colored pencils, don't put them back in there. I'm going to leave this so I can see them. There's a little thing back there. On your way out, because we have 30 seconds, drop anything that you borrowed from me in there so I can keep it separate to make sure we stay as healthy as we can. And then, seriously, these next couple of days, we'll just finish this handout as we go.
We don't have any.
No, nothing you have to do today, nothing you have to submit for me before tomorrow. Just take that home with you, and we'll probably do like 3 and 4 at least tomorrow. Okay, so the back of that first picture. Sweet? Please.
Do you know what we do before we're done spring break on that Thursday?
We'll be into the next chapter, but the Thursday right before, I don't know how far we'll get it or how fast we'll get there, you know what I mean? So, but we'll be into a different chapter for sure. That's okay.
I'm going to Hawaii.
Nice, that sounds awesome. So as we get closer to that, let's have this conversation again, and I'll make sure that you're ready to go.
Yeah, I'm trying to get it because I
Smart.
usually wait until the last minute.